Good day, friends, and welcome to today's WASE online channel. I'm Philip, your instructor. But before we start our lesson for today, I need you to subscribe for our channel if you've not already done that. We need your subscription for the survival of this program. To do this, just go below this video and tap the subscribe button. Thank you so much for doing this for us. Now let's look at our activity for today. We will start with a new topic today: bearings and vectors. Today we'll be looking at part 1 of bearings and vectors. We have divided this topic into 8 main parts, from part 1 to part 8. In this part, we'll be focusing on the following topics: 1. Introduction to bearings. 2. Bearings of a point from another. And 3. Reverse or back bearings. Introduction to bearings. Now, if you are asked to give a direction to a place, you can do that by using tangible landmarks. For example, you can say, move to the left towards the white-story building. When you get there, turn right straight towards the park. And once you get to the park, just continue moving until you meet the filling station. So as you can see, this is one method by which you can give direction to a place, by making use of tangible landmarks. We can also give directions in terms of angles. Bearings help us give directions in terms of angles. There are 2 types of bearings that we will be looking at. So we have compass bearings and 3-figure bearings. Let's look at the compass bearings. And the compass bearings, we'll be looking at the point of the compass. This is our compass. This compass has the 4 main cardinal points: north, south, east, and west. As you can see from the screen, there are other points within the 4 main cardinal points. It is very important for us to note that we generate these other points by combining the 4 main cardinal points, and in doing so we make reference to 2 main cardinal points, the north and the south points. So when a point is between the north and the east cardinal point, we refer to that point as northeast. Remember, we started from the reference point north to east. It would be east north, but rather northeast. Also, when a point falls between the cardinal point north and west, we would refer to that point as northwest. Remember, the north point is the reference point, so it wouldn't be west north, but rather northwest. Another reference point is the south point. So when we have a point in between the south pole and the west pole, we would have southwest. Again, if you have a point in between the south and the east, it will be southeast, not east south or west south. So remember these. Now let's look at how we can use compass bearings to determine directions. Let's take the town A. Let's assume town A is on this position, not 30 degrees west. How do we represent town A using compass bearing? To do this, let's first draw our cardinal points. First, we are being told that town A is at position northwest. We can locate this position between the north and the west cardinal point. So town A will be somewhere here. Now, the exact position of town A is 30 degrees northwest. So, using the North Pole as reference point, we will move 30 degrees towards the west. Remember, we are moving from the north towards the west 30 degrees. So, that is the position of town A, 30 degrees northwest, or not 30 degrees west. Let's look at another example. Town B. It is at a position south 70 degrees east. What this means is that town B is between the south and the east pole, and it is 70 degrees when we move from the south towards the east. We will first draw our cardinal points. We would then move 70 degrees from the south towards the east. B will be located at this position. Let's look at town C. It is located at a position not 50 degrees east. What this means is that from the north towards the east, we would move 50 degrees. As usual, we would first draw our 4 cardinal points. We will then move 50 degrees from the north towards the east. Our town C would be at this position. Let's look at another set of examples. We are to use compass bearings to determine the directions of the following given points. Let's start with the first example. The point is A, and it is located at the position between the north and the east pole. So clearly, point A will be at a position northeast. But the question is, we need to know the exact location of point A in terms of angle. As you can see from the screen, when you move from the North Pole towards the East Pole, A is located at the angle 25 degrees. So A is at the position not 25 degrees east. That is the compass bearing of the point A. Let's look at the second example, point B. It is at a position between the south and the west pole. So clearly, it will be at a position southwest. But we need to know the exact angle at which it is located. Now, when you look at the diagram given to us carefully, you realize that 30 degrees has been given. But this 30 degrees is between the point B and the west pole. The truth is we cannot use these 30 degrees because west is not a reference point. The reference point is south. So our movement should come from the south towards B, not from the west towards B. So what this means is that we would have to find the angle between B and south, or the south pole. How do we find this angle? Remember, the angle between the west pole and the south pole is 90 degrees. So if we have 30 degrees between the west and the point B, what it means is that to find the angle between the point B and the south pole, we simply need to subtract 30 from 90. This will give us 60 degrees. So now we can move from the south reference pole towards the point B at an angle of 60 degrees. So this means that the point B is located at the position south 60 degrees west, and that will be the compass bearing of the point B. Let's look at our final example. The point C is located between the south and the east pole. So clearly, it is at the position southeast. In this case also, the angle given to us, the 33 degrees, is between the point C and the east pole. We cannot use the east pole as a reference point. Our reference point should be the south pole or the north pole. In this case, we are using the south pole. So we will need to find the angle between the south pole and the point C. We do this by subtracting the 33 degrees from 90 degrees. That will give us 57 degrees. So now moving from the south pole towards the point C, we would have to move an angle of 57 degrees. What this means is that C is located at the position south 57 degrees east, and that is the compass bearing of the point C. Let's look at the second type of bearing, the three-figure bearings. This bearing is called three-figure bearing because angles are given in 3 digits from 000 degrees to 360 degrees. Remember, in terms of degrees, the minimum angle you can ever measure is 0 degrees, and the maximum angle you can ever measure is 360 degrees. Angles such as 360 degrees, 250 degrees, 180 degrees, 115 degrees are all in 3 digits. So of course we do not need to worry ourselves too much about these types of angles. The problem is when the angles are given to us and they are not in 3 digits. For example, 0 degrees. 0 degrees is just in 1 digit. But because in 3 figure bearings, angles are to be recorded in 3 digits, we cannot say 0 degrees. We can say 0, 0, 0 degrees. Now let's take the angle 35 degrees. This angle 35 degrees is a 2-digit angle. In 3 figure bearing, we cannot write it as this 35 degrees. We can, however, write it as 035 degrees. So this is one of the things you need to note about 3 figure bearings. Angles are always recorded in 3 digits. The second item we need to note about 3 figure bearings is this. This bearing is read in clockwise direction from the geographical north of the cardinal point. In other words, we use the North Pole or the North Cardinal point as our starting reference point. And here again, we need to note that it is only angles that will be stated in 3 digits. But we always need to bear in mind that we have to start counting from the geographical North Pole of the cardinal point. Let's look at an example. So we've been given the angle 25 degrees, but because we are in 3 figure bearings, it should be 025 degrees. Now we are to represent this angle or this direction on a diagram. Let's quickly look at how we will do this. First, we have to draw our cardinal point, showing just the geographical North Pole. We will then read from the North Pole in clockwise direction the angle 25 degrees. Our point B will be located at this position. We'll be looking at a lot more examples, but at this point, let's look at something else. Let's look at arrow directions in bearings. In geometry, we usually use arrows to show directions. So the arrowhead will be used to show where a movement is starting from and where that movement is going to. In bearings, the words from and to are very important. So when you hear the statement from a point, what it means is that you are moving from a point. In other words, an arrow would have to move from that point. And when you hear of the statement to a point, What that also means is that we are moving towards that point, so an arrow would have to move towards that point. Let's see if we can come up with something based on what we've just learned. So we have the statement bearing of B from A. What this statement means is that we are moving from A and we are going to B. You have from A, so we are moving from A. So let's draw an arrow diagram to represent this movement. We are moving from the point A, so we would first indicate the point A. We then move, so we'd use an arrow to show our movement. Where are we moving to? We are moving to the point B. So let's show our destination, the point B. So that is an arrow diagram we can use to represent the bearing of point B from the point A. Let's look at another example, the bearing of the point D from the point M. In this case, we are moving from the point M and we are going to the point D. Another example, bearing of K from H. In this case, we are moving from H to K. Fourth example, bearing of O from T. In this case, movement is from T to O. Final example, bearing from P to R. In this case, we are moving from P and we are going to R. Now, let's look at the bearings of a point from another point based on specific angles. Example 1. Bearing of A from B is 60 degrees. How do we represent this using a diagram? First, we would have to draw our cardinal point. Second, we would have to note from the statement that we are moving from the point B and we are going to the point A. So we will need to show our point B, the starting point, at the origin of the cardinal point. Remember, we are doing 3-figure bearing, so we would have to start counting from the geographical North Pole clockwise 60 degrees. We will now show our arrow diagram which indicates the movement from B to point A. We would finally show our destination point, which is the point we are going to, that is point A. So this is the diagram you would use to show the bearing of A from B being 60 degrees. Let's look at another example. Example 2. Bearing of G from K is 220 degrees. Let's represent this using a diagram. We would first draw our cardinal point. Let's note that the bearing is from the point K and we are going to the point G. So the point K will be at the origin of the cardinal point. We would then measure 220 degrees starting from the North Pole clockwise. So this will be our 220 degrees. Let's note that a movement from the north to the east is 90 degrees. A movement from the north to the south is 180 degrees. A movement from the north to the west is 270 degrees. And a movement from the north clockwise back to the north is 360 degrees. So the angle yellow would represent 220 degrees. It's now time for us to draw our arrow diagram from the point K to the point G. Let's look at the next example. Example 3. Bearing of A from B is 285 degrees. Let's represent it on a diagram. We will first draw our cardinal point. Our bearing is from B, so the point B will be at the origin of the cardinal point. We will then measure the angle 285 degrees from the North Pole. Then we would show our arrow diagram moving from the point B to the point A. Example 4. Bearing of F from N is 112 degrees. Let's represent it with the diagram. We would first draw our cardinal point. Our bearing is from the point N, so we'll put the point N at the origin of the cardinal point. We will then measure 112 degrees from the North Pole clockwise. We will then draw our arrow diagram from the origin, the point N, to our destination, the point F. I hope that was very simple. Let's look at back bearings. Back bearings. This is also referred to as reverse bearings. To better appreciate this, let's first draw an arrow diagram to represent the bearing of B from A. So, this statement simply means we are moving from the point A and we are going to the point B. This is the arrow representation of the statement. Now, The back bearing of this statement or the reverse bearing of this statement is the bearing of A from B. Is simply the opposite of the first statement. How do we represent this using a diagram? You simply have to move from the point B to the point A, as shown in the diagram below. Now, that's how back bearings are done. We'll be applying this concept in cases where angles are given. In the meantime, we'll be looking at a few tricks that would help us when we come to this back bearing stuff. Let's look at the first trick we need to know. The diagram on the screen shows 2 points, point A and point B. The point A is at the origin of one cardinal point, and the point B is also at the origin of another cardinal point. Now, let's assume that we are moving from the point B to the point A. We'll be using an arrow diagram to show this movement. So, this arrow diagram shows that we are moving from the point B to the point A. Again, assuming we are being asked to indicate or to show the angle of this particular movement from B to A, where would you show this angle? Okay, it is this black angle you would need to indicate. How did we do this? Remember, B is the origin, so we start from the north pole of B and we move clockwise until we meet the blue line, which is the arrow diagram. So that is why that black angle represents the bearing of A from B. Remember, from B, we are moving from B to A. Now, what is the back or reverse bearing of this particular bearing? It should be the opposite, which is the bearing from A to B. How do we show this reverse bearing with an arrow diagram? All we need to do is to flip the arrow backwards. So that's all we need to do. So let's quickly do that. So this blue line with its arrow turned backwards from A to B should be the reverse, which is the bearing of B from A. So, what do you think is the angle for this reverse bearing from A to B? To do this, we would have to start from the north pole of the point A, move clockwise until we meet the blue line. So let's quickly do this. So, this yellow angle you see on your screen is the angle of our reverse bearing. You need to remember this, since we'll be very soon applying it in calculations. Let's look at another example. In this example, we have 2 points, K and H. So we're going to find the bearing of H from K, then afterwards we'll look for its back bearing, which is the bearing of K from First, what is the bearing of K from H? Remember, in this question, we are moving from H to K. What this means is that the H is our origin. So we start counting from the north pole of our origin, which is the H, and we will move clockwise until we meet the blue line. This will be represented by this green angle. So the green angle is the bearing of K from H. Remember, we are moving from H. Let's do the back bearing, which is the bearing of H from K. So this time around we are moving backwards, but we are starting from K to H. So we would go to the north pole of the point K and we will count clockwise until we meet the blue line, which will be indicated by this yellow angle. So this yellow angle is the bearing of H from K. Let's look at another trick. In this trick, we'll be looking at what alternate angles or Z angles are. So let's take two parallel lines. Parallel lines are lines that have the same distance between them at any point in time, and they either move in the same direction or move in opposite direction to each other. Now let's draw a transversal through these two parallel lines. This blue line is a transversal because it is a straight line that would pass through both parallel lines. What can you see in this diagram on the screen? Well, actually I can see a Z shape. Let's look at these two angles in the Z shape. These angles M and N are called Z angles. They are also called ordinate angles. What we will need to note is that Z angles or ordinate angles are equal. Therefore, the angle M is equals to N. Now, let's apply these concepts of ordinate angles in the next slide. Let's draw the cardinal point showing north, south, east, and west. Let's draw a second cardinal point. We would now draw a line to connect the origins of the two cardinal points. Now, let's note that the north-south plane of the first cardinal point is always parallel to the north-south plane of the second cardinal point. If the north-south plane of both cardinal points are parallel, then can we say the black line that joins the origins of both cardinal points is a transversal? Absolutely. That black line will be a transversal. What this means is that alternate angles can be formed in this diagram. Let's look at that carefully. We would first draw our Z shape. What this means is that These two yellow angles alternate with each other, so they are the same. In other words, they are the same because they are Z angles. Let's look at another example. We have another two cardinal points. It is also very important for us to note that whilst the north-south plane of two cardinal points are parallel, the east-west planes of two cardinal points are also parallel. So in this case too, the blue line that joins the origins of the two cardinal points can be described as a transversal, which means that a Z shape can be found in this diagram as well. Let's look at the Z shape. Let's now indicate the positions of the two Z angles or the two ordinate angles. These two angles are also equal because they are Z angles or ordinate angles. Please do not forget this. Remember, we'll need this idea to solve a problem in the future. Let's also note the following. First, the bearing of A from B is 60 degrees. We are going to draw this bearing. That is the drawing of this bearing. We have now been able to draw a diagram to represent this bearing. But let me ask, what do you think is the value of the angle marked black? The clue for this problem is this. Remember that from the north pole to the east pole, the angle is 90 degrees. So if the yellow angle is 60, what it means is that the value of the S angle will be what? Well, it will be 30, because all you need to do is to subtract the 60 from 90 and you get 30. Let's look at another example. The bearing of A from B is 220 degrees. Let's draw a diagram to represent this bearing. Alright, so that is the diagram. From the north pole to the red line is 220 degrees. What do you think would be the value of the black angle marked S? Let's start by looking at the clue. From the north pole to the south pole, the angle is 180 degrees. And from the north pole to the red line, the angle is 220 degrees. So how do we find the value of the angle marked S? Okay, you simply need to subtract 180 degrees from 220 degrees to get the value of that angle. So let's do that quickly. So that angle marked S would be 40 degrees. Let's try example 3. The bearing of A from B is 285. let's draw a diagram to represent this bearing. So that is the diagram to represent the bearing of A from B, which is 285 degrees. But how do we find the value of the angle marked S? Any idea? Okay, let me give you the clue. When you move from the North Pole to the West Pole, you have moved an angle of 270 degrees. We also know that the bearing, which is from north to the red line, is 285 degrees. What then is the value of the angle marked S? Well, to do this, we would have to subtract 270 degrees from the bearing, which is 285 degrees. So our answer is 15 degrees. That is the value of the region marked S. Let's do the final example. The bearing of A from B is 112. So let's represent this using a diagram. So that is our diagram. Again, how do we find the value of this black angle marked S? Well, let me give you the clue. From the North Pole to the red line, the angle is 112. Now, from the North Pole to the East Pole, that angle is 90. So how do we find the value of the angle S? What do you think? Okay, so let's solve this together. To find the value S, we will need to subtract 90 degrees from 112 degrees. So when you do this, the value of the S will be 22 degrees. Now, let's apply everything we've learned into solving a few problems. Example 1. The bearing of A from B is 60 degrees. What is the bearing of B from A? So first, we would have to draw a diagram showing a bearing of A from B, which is 60 degrees. Remember, because we are moving from B to A, we will need to draw our first cardinal point with the origin B, because that's the starting point, the origin. We will then move 60 degrees clockwise from the North Pole of the point B. Then we will draw our arrow line from B. Let's note that our destination point is the point A. So we'll have to join the arrow line to the destination point, point A. Okay, so that's the diagram for bearing of point A from B, which is 60. Now, the second part of the question asked us to find the bearing of B from A. So what this means is that at position A, we're going to turn backwards and move towards point B. This is a clear example of back or reverse bearing. To be able to do this, we would have to draw another cardinal point at the position A. So let's quickly do that. We will then start measuring our angle from the north pole of the position A, or the point A, backwards until we meet the green line. Now this angle represented by the red arc is the bearing of the point B from the point A. But how do we find its actual value? Let's quickly look at how we can do this. To be able to do this, let's determine the pair of Z angles in this diagram. We would first draw our Z shape in the diagram. You would realize that the angle 60 degrees alternate with this blue angle. This means that the blue angle is also 60 degrees. How do we measure the angle between the north pole of the point A and the green line? This is very simple. All we need to do is to add 180 degrees to 60 degrees. Remember, when you move from the north pole to the south pole, you have moved 180 degrees. And when you move from the south pole to the green line, you have moved 60 degrees. So the total movement will be 180 degrees plus 60 degrees. And when you add the two, you would get 240 degrees. Therefore, the bearing of the point B from the point A is 240 degrees. That is the answer to this problem. Let's look at example 2. Example 2. Bearing of A from B is 112 degrees. What is the bearing of B from A? In the first part of the question, the bearing is from B. So what this means is that the starting point or the origin will be B. So let's draw the cardinal point with the point B as the origin. Next, we would move from the north pole of the point B in clockwise direction through an angle of 112 degrees. We would then draw our arrow diagram from the point B. Since our destination is the point A, we would have to end in the point A. So that's how we're going to draw the bearing of A from B being 112. That's how it will look like. The second part of the question wants us to find the bearing of B from A. So what this means is that whilst we are at the point A, we would have to turn backwards and go back to our starting point. This is another example of back or reverse bearing. To do this, we would have to draw another cardinal point at the point A. So let's quickly do that. We will then move from the north pole of the point A in clockwise direction back to the green line. This movement is shown by the red arc. Now let's find the value of the angle marked S. To find the value of the angle marked S, let's note that to move from the north pole of B to the green line, we would move an angle of 112 degrees. Also, a movement from the north pole to the east pole of the point B is an angle of 90 degrees. So to find the value of x, we simply need to subtract 90 degrees from 112 degrees. 112 degrees minus 90 degrees would give us 22 degrees. What this means is that the value of the S, or the value of the angle S, is 22 degrees. Now let's determine our pair of Z angles, or our pair of ordinate angles. So draw our Z shape first. As you can see from the screen, the angle marked S is ordinating with this blue angle. This means that the value of the blue angle is the same as the value of the angle S, which is 22 degrees. Now, how do we determine the bearing of the point B from the point A? To do this, we first have to move from the north pole of the point A to the west pole. This has a value of 270 degrees. Then we move from the west pole to the green line. Remember that angle, the blue angle, has a value of 22 degrees because that angle is the same as the angle S. So the total movement will be 270 degrees plus 22 degrees. 270 plus 22 degrees would give us 292 degrees. Therefore, the bearing of B from A is 292 degrees. Let's look at example 3. Question 3. The bearing of E from D is 240 degrees. What is the bearing of D from E? In the first part of the question, the bearing is from D. What this means is that our origin is the point D. So we'll start with the point D by drawing our cardinal point with the point D as the origin. Now, starting from the north pole of the point D, we are going to measure in clockwise direction the angle 240 degrees. We will then draw our arrow line at this point. The arrow line would have to meet the destination point that is the point E. We are done with the first part of the question. We've been able to draw the bearing of the point E from the point D, and it is 240 degrees. Let's look at the second part of the question. The second part of the question is asking us to find the bearing of D from E. How do we do this? First, we would have to draw another cardinal point at the point E. So let's do that quickly. We will then measure from the north pole of the point E in clockwise direction the angle between the north pole and the green line. So let's quickly show that. So we've been able to show that angle with the blue color, but we will need to find its actual value. To be able to do this, let's first find the value of this angle marked S, that is the black angle. To find the value of this black angle, all we need to do is to subtract 240 from 270 degrees. Remember, when we move from the north pole to the west pole, we have moved an angle of 270 degrees. But when we move from the north pole to the green line, we have moved an angle of 240 degrees. So to find the value of the angle marked S, we will need to subtract 240 degrees from 270 degrees. So it's as simple as that. When you subtract 240 degrees from 270 degrees, you'll be getting 30 degrees. What this means is that the angle marked S, that is the black angle, is equals to 30 degrees. At this point, we can find the bearing of D from E, which is the blue angle. How do we do this? To be able to do this, let's first find our pairs of Z angles. So we'll have to draw the Z shape. After drawing the Z shape, you realize that the black angle, which is 30 degrees, would alternate with this red angle. What this means is that the angle marked red is also 30 degrees. So at this point, it will be very easy for us to find the value of the angle marked blue. How do we do this? The clue is this. Remember, from the north pole to the east pole, the angle between them is 90 degrees. So if the red portion is 30 degrees, to get the blue portion, just subtract the 30 degrees from 90 degrees. When you do this subtraction, you would get 60 degrees. Therefore, the bearing of D from E is 60 degrees. Let's look at example 4. The bearing of G from K is 285. What is the bearing of K from G? The first part of the question is saying that the bearing from K to G is 285. So let's first remember that with the origin where we are starting from is K. So let's show our cardinal point with K being the origin. We will then draw our angle 285 degrees starting from the north pole of the point K in clockwise direction. So let's quickly do that. We will now have to draw our arrow diagram, moving from the origin, which is K, to the destination, which is the point G. At this point, we have been able to draw the bearing of G from K, which is 285 degrees. The second part of the question is, however, asking us to find the bearing of K from G. So what this question is saying is that we should just turn backwards and do the back bearing. So let's quickly look at how we do this. To be able to do this, we would first need to draw another cardinal point at the point G. We will then draw our angle from the north pole of the point G to the blue line. So that angle is being represented by the red arc. Now, at this point, what do you think is the value of the angle marked S? To be able to find the value of angle S, let's remember that when we move from the north pole to the blue line, that angle is 285 degrees. Also, when we move from the north pole to the west pole, that angle is 270 degrees. So to find the value of S, we simply need to subtract our 270 degrees from the 285 degrees. When you subtract 270 degrees from 285 degrees, you would get 15 degrees. What this means is that the value of the S is 15 degrees. At this point, can we use the value of S to find the angle marked blue? What do you think? Well, the blue angle and the angle S are alternate angles, so they are equal. What this means is that the blue angle is also 15 degrees. At this point, it will be easier for us to find the bearing of the point K from G, that is marked by the red arc. To find this, we first need to move from the north pole to the east pole, which is 90 degrees. Then we'll move from the east pole to the blue line, which is 15 degrees. So what this means is that we would have to add the 90 degrees to the 15 degrees to get that bearing. When we add the 90 degrees to the 15 degrees, we would get 105 degrees. So the bearing of K from G is 105 degrees. Well, friends, this brings us to the end of part 1 of bearings and vectors. You can now go to the part 2 of bearings and vectors. In part 2, we would look at a lot of distance bearing problems. Stay safe, good friends, and remember to subscribe for this channel if you've already not done that. By going to the bottom and subscribing, you can learn a lot of topics in mathematics and science from us. Thank you so much. We'll meet again in our next video.